Hello everyone, this is the lesson 8. The goal is summarize feature of the graphs of higher degree polynomials. Let's take a look. Let me introduce this website later. Let's talk about this one first. So we have nth degree polynomials. So like x to the third power or 4, 5, 6. Everything is polynomial, right? Then we have at most n minus 1 peaks and valleys, local extrema. Means that if we say that, example, if we have, let's say that 3x to the fifth minus 4x to the 4 plus 2x, 12, x to the second power minus x plus 4. How about that? Yeah, this is a polynomial. Okay, then they said at most, that is that means maximum, means maximum. n minus 1, peak and valleys, means that log, let me write down. A little bit ugly. Oops. Forgive me. Hold on a second. How about that? Better, right? This is a peak. This is a valleys. How about this one? Let me add. If we have this kind of, yeah. So this is a peak. This is a valley. This is a peak. This is a valley. Okay, so in the case we have n minus 1, so if we have n equal to 5, means if n equal to 5, n minus 1, so n minus 1, which is 5 minus 1 equal to 4, excuse me, at most. So it can be less than 4, right? So 4 is the maximum we can have. At most. 4 has peaks and valleys. So basically they said the local extrema, right? So in that case, we say the local maximum. In that case, the local minimum. In that case, the local maximum, local minimum, local maximum, local minimum, right? So everything we called local extrema, all right? Okay, now the next sentence said that at most n horizontal intercepts. That means n horizontal intercept means that x-intercept. So x-intercept means the point or graph touched x-axis, right? The point on the x-axis, right? So we know that what x-intercept means, so I'm not gonna write down. Okay, then we know x-intercept, there will be solution because we had previously quadratic function, and then we set up the other side equal to 0, solve, what is the solution, right? So that is same as x-intercept, x equal to some number when y equal to 0. That's the horizontal intercept, all right? And solution, also we called root. So they are same, x-intercept, solution, root, all right? Everything on the x-axis. Make sense? That is a horizontal intercept. Okay, in that case, nth degree polynomial, that n most, and horizontal x-intercept, and solutions there, right? So we have, in example here, 3x to the fifth. That means the 5 x-intercept there, 5 solutions there, 5 roots there, and most, the maximum we can have. We cannot have more than 5, right? So maximum, no more than. All right. Okay. Now, next sentence. If n is even and behavior. So and behavior means this is and behavior. This part. So just to think, the end of graph. How about that? End of graph. Okay, end of graph equals, it might goes to negative infinity. So in that case, it goes to negative infinity, right? And here, end behavior, the graph goes to positive infinity. So we denote positive infinity, right? Okay, they say that look like both arms up, both arms down, right? So n equal to even. So both arms both arms up like up or down, right? So let me do it here for you. This is not one because this is the one is down, one is up, right? So I'm gonna make both arm up means like this parabola. That's the common, right? And then we can have this kind of graph also, both arm up, right? Looks like, right? And then here, both arm down. There is parabola open downward, right? And also we can make this graph also arm down, right? Okay, now this is when n is even, means the polynomial we read the highest degree, right? We read the greatest exponent, right? So this is for even n is even, all right? Okay, next we have n is odd. Then n behavior looks like left arm up, right arm down, left arm up. Okay, so this one looks like this. Left arm up, right arm down. This one looks left arm up, down. Yeah. And this one, right Hold on 1 second. Left start. Left arm down, and right arm up. So this one looks like this, yeah? Or is it? So bad. Okay, then this is N is odd, right? All right, let me explain to you more by using the polynomial. So this polynomial, I want to go over the decimals here. Okay, so this is the one. Okay, let's click this one, 2x to the 4th power. Yeah, so n behavior goes to the positive infinity, right? So I cannot annotating from here. So n behavior goes both arm up, right? Can you see that? And then n-1 peaks and valley. So this is this polynomial n equal to 4 minus 1, which is 3, has peaks and valleys, right? So we can see 1, 2, 3. Okay. Oh, I can do that. This is a local minimum. 1, 2, 3, right? So minimum, maximum, 0, 1, maximum. This is a minimum, right? Right? So n-1, which is 4 minus 1, 3, local extrema. And let's take a look, horizontal intercept, which is x-intercept. So there is n at most. 1, 1, 2, 3, 4, n. So we have a 4, right? At most 4, maximum 4 has. It can be less, right? Because they said at most. Make sense? Okay, now this one is both arm down, right? So n behavior, the graph goes to negative infinity. Okay, and even, right? So both even. The previous one it was even, and this is even because n equal to 4. So n-1 local extrema. So n-1, which is a 3. 1, 2, 3. Yes? And then at most 4 x-intercept, which is the solution, right? So 1, 2, 3, 4. That is x-intercepts solution, right? Okay, now this one, n equal to odd, then one is left arm, right arm down, or left arm down, or and right arm up, right? So look, in that case, negative 2x to the 3rd power, we have a negative, right? If a negative, left arm up, and then right arm down. This is the orange one is the positive, then means that the first coefficient is positive, right? Positive 2, then left arm down, and then right arm up. Can you see? Okay, we can see that 3 minus 1, which is 2, and most local extrema, right? So 1, 2, we knew, right? And then how many x-intercept at most? It's a 3, right? So let's check that. Check it out. So 1, 2, 3. Yes? Okay. Very good. Now we know the polynomial, the parabola. So those are parabola, right? Open upward, downward. We know this is linear, right? Okay, let's go back. Maybe you should check. Yeah. Okay. Now, let me go back. Okay, we have only one example here. So let's do it. All right, so this is a piecewise function, means that the function we denote as a piece. All right, okay, now we have the cost function from electrical cost, and then X is a kilowatt hours. Okay, if the customer use between 0 to 100, they're using this piecewise function, and customer use 100 to 500, then they're using this equation. If a customer use more than 500, they're using this one. So I set up my house. I set up peak time from the 4 p.m. to 9 p.m. If I'm using my electricity between those time, I have to pay double. That's how I set it up for my electric bill. So the PG&E must be used, those kind of equation, right? Okay, now what is monthly charge if 1100 kilowatt hours, right? Okay, so 1100, let's take a look, where's 1100? So number one or number two or number three, right? So 1100 must be number three, right? So X equal to 1100. So for equation 3, so we have a 67.90 plus 0.119 x minus 500. So 67.90 plus 0.119 x will be 1100 minus 500. If we calculate, okay, then we get 67.90 and plus 0.119. Inside we have a 600. Then we calculate, then 71.4. We get 193 and 3, right? So this is the money. So we have a 139. 3 means 30 cents, right? 139, right? Yeah. Okay, so let's check that second one. So we have monthly charge for 450. So 450 is here. So equation number 2, right? So X equal to 450 for equation number 2. So equation number 2, we have a 22.70 plus 0.113 x minus 100. So that will be 22.70 plus 0.113 x is 450 minus 500 equal to 22.70 plus 0.113, and inside the parentheses, 350. So we calculate, we have, wow, that is a 2,309 and 55. How can be? Oh, I copied wrong. Sorry. So there will be 100, right? 100. And so this is a 350. And we got something wrong with this one, right? 220. Okay. Sorry about that. I copied wrong. Because 22.70, I made a 2,270. So let me do here 22.70, 28.35, right? So sorry about that. 28.35. Okay. Thank you for watching. Bye.